Jai Hind students, how are you all? So, in the previous lecture, we have discussed Wheatstone bridge, then we have discussed slide wire bridge, and then we have also discussed potentiometer, and we have discussed the applications of these electrical arrangements, isn't it? So, now it's turn to apply those theoretical concepts and solving some selected numericals, right? So, in this session, we will be discussing these 5 numericals based on these electrical instruments, or you can say arrangements, right? So students, let's start with the first question. It's based on potentiometer. So first question is, a potentiometer wire of length 100 cm has a resistance of 10 ohm connected in series with a resistance and a cell of EMF 2 volt of negligible internal resistance. So what to do is, let us depict this particular question diagrammatically. So suppose this is the potentiometer wire of 100 cm length and it has a resistance of 10 ohm. These are the 2 points, suppose. These are the 2 endpoints of a potentiometer, right? And it has a resistance of 10 ohm connected in series with a resistance and a cell of EMF 2 volt. Suppose this is the cell of EMF 2 volt and this is the resistance. All are connected in series. This is suppose R, right? A source of EMF of 10 millivolt, this is millivolt, is balanced against a length of 40 cm of the wire. So, this is suppose the balancing length over here. This is the galvanometer, and it is balanced by another source of EMF. It's given to be 10 millivolt. So, 10 into 10 to the minus 3 volt, right? And this distance is given to be 40 cm. So rest of the distance, it will be equal to 60 cm. Clear students? The net resistance offered by the entire wire is 10 ohm. So this is the situation. And what our objective is to find out the value of the external resistance. So we need to determine the value of capital R. This is to be determined. Right? So this is the question. Okay. Now let's make use of the concept. First and foremost, the resistance of this 100 cm resistance potentiometer wire is given to be 10 ohm, right? So for 100 cm wire, the resistance is 10 ohm. Therefore, for 1 cm of potentiometer wire, the resistance will be 10 by 100 ohm. Therefore, for 40 cm of the potentiometer wire, the resistance offered by the potentiometer wire will be 10 over 100 multiplied by 40. So it will be equal to 4 ohm. So this part is offering resistance of 4 ohm. So out of 10 ohm, this part is offering 4 ohm. So the rest 60 centimeter would offer resistance of 6 ohm. Right? So 10 by 100 is the resistance offered by the potentiometer wire per unit its length. So by using this fact, we can determine the resistance offered by 40 cm length as well as resistance offered by 60 cm length of the potentiometer wire. Clear students? Okay. The current from here, suppose it is I. So current I would be given by net EMF over net resistance. It is given by net EMF divided by net resistance. Net resistance is the sum of the external resistance and the internal resistance. Over here, the internal resistance of the source is given to be negligible, right? So what we get is net EMF is 2. Net resistance is R plus this resistance. The entire resistance offered by the potentiometer wire is 10 ohm. So it will be 10 plus R. So put this as equation number 1. Right, students? Now, let's deal with the second part. A source of EMF of 10 millivolt is balanced against the length of 40 cm of the wire. So this EMF is balanced by this length of the wire, which is offering resistance of 4 ohm. So this EMF E dash, also it is given, E dash, it will be equal to current, the same current must be flowing through it, multiplied by the resistance offered by this segment. That is 40 cm length of the potentiometer wire is offering a resistance of 4 ohm. So multiplied by 4, right? So put this as equation number 2. Substitute the value of I and E dash and then we can solve to get the value of external resistance capital R. So let's do it, students. E dash, it's given to be 10 millivolt. So it will be 10 raised to the power minus 2. Current, it's given to be 2 divided by 10 plus R multiplied by 4. Right? So let's try to solve it. So what you get is 10 plus R is equal to 8 divided by 10 raised to the power minus 2. That would be 800. Or R would be equal to 800 minus 10 is equal to 790 ohm. So student, this must be the answer. So the external resistance, its value is 790 ohm. So it was a very good question based on potentiometer, right? So students, we are over with question number 1. So now let's proceed to question number 2. Okay, question number 2 is again based on potentiometer, right? So let's go through this question first. With a certain cell, the balance point is obtained at 65 cm from the end of a potentiometer wire. And with another cell whose EMF differs from that of the first by 0.1 volt, the balance point is obtained at 60 cm. We are supposed to find out the EMF of each cell. Again, this is an interesting question. So, again, I read the question. With a certain cell, suppose its EMF is E1. The balance point is obtained at 65 cm. So, E1 is proportional to L1, which is 65 cm. L1 is given to be 65 cm. We are aware of the principle on which the potentiometer works. The working of the potentiometer is based on the principle that when a constant current is made to pass through a wire of uniform cross-sectional area, then the potential drop across any portion of the wire is directly proportional to the length of that portion of the wire. So that is what I have made use over here, right? E1 is the EMF of the first cell and the balancing length is supposed L1, which is given to be 65 cm. Okay. With another cell, suppose its EMF is E2. So obviously balancing point will differ. Balancing point is obtained at 60 cm. Suppose L2. L2 is equal to 60 cm. Now look, it is directly proportional to the length of the portion of the wire, right? So obviously L1 being greater than L2, therefore it implies that E1 would be greater than E2. E2 would be smaller than E1. And it's mentioned with another cell whose EMF differs from that of the first by 0.1 volt. This is the key point. So, E1 is greater than E2 and it differs by 0.1 volt. So, what I mean to say is that E2, it is less than E1 by 0.1 volt. It is given. It is the given statement. And from L1 and L2 and from this particular fact, we came to know that E1 is greater than E2. So E2 is less than E1 by 0.1 volt. It's already given in the question, right? Okay, let's try to solve it. Dividing these two, what we get is E1 by E2, it will be equal to L1 by L2. So E1 divided by, in place of E2, we can write E1 minus 0.1. So it will be equal to L1 by L2, that is 65 by 60, right? So 13 by 12. So on cross multiplication, what we get is 12 E1 is equal to 13 E1 minus 1.3. That is E1 is equal to 1.3 volt. Correct, students? And E2 is less than E1 by 0.1 volt. Therefore, E2 is equal to 1.3 minus 0.1. That is 1.2 volt. So this must be the value of the EMF of the first cell, and the EMF of the second cell, which is less than the first one by 0.1 volt, would be obviously 1.2 volt. Correct, students? So here again we have made use of this particular concept on which the working of potentiometer is based upon. Clear? So we are done with question number 2 as well. Question number 3, another very interesting and simple question. These type of questions are very important from comparative point of view as well. These are actually thoughts category questions, right? So let's attempt the third one. Third one is, please consider on the diagram. The two cells are given of EMF E1 and E2. Just consider on this particular diagram. These are the two cells connected in an opposite manner. It will send current along this direction while it will send current along this direction, right? And EMF E1 is dominating. I mean, this cell is dominating. E1 is given to be greater than E2. Now, when a potentiometer is connected between the points A and B, potentiometer when it is connected between A and B, the balancing length of the wire is 300 centimeter. On connecting the same potentiometer between the points A and C, the balancing length is 100 centimeter, right? So what to do is, let me draw the diagram over here. These are the 2 points, A and B. This is E1 and this is the potentiometer, right? This is suppose the potentiometer. So only EMF E1 will come into the circuit. E2 will not have any role to play in the first case, right? When it is connected between the points A and B. This is case 1. So in this case only E1 will come into play and it is proportional to L1 as per the principle. And L1 is given to be 300 centimeter. Now second case. Now this is point A, this is point B and this is point C, right? This is of EMF E1, it is of EMF E2 and the same potentiometer is connected between the points A and C, right? In this case obviously the balancing point gets changed and it is 100 centimeter. Now look, what's the net EMF between the points A and C? It is E1 minus E2. Why E1 minus E2? Because E1 is greater than E2 and both the cells are oppositely connected. That is, they are connected in such a manner so as to send current in the opposite direction. In case the cells were connected so as to send the current in the same direction, then the EMF would have added up. But in this case, since they are sending current in the opposite direction, therefore the net EMF would be given by the difference of the EMFs of the two individual cells, right? And since E1 is greater than E2, therefore the net EMF across the points A and B would be E1 minus E2. So it will be proportional to L2. L2 is the new balancing point which is given to be 100 centimeter, right? So let's solve it. Put this as equation number 1, this as equation number 2. On dividing second divided by first, what we get is E1 minus E2 divided by E1 is equal to L2 by L1, which is equal to 100 by L2 is given to be 100. It will be equal to 100 by 300. Right? That is 1 by 3. So let's try to solve it. On cross multiplication we get 3E1 minus 3E2 is equal to E1. Or in other words, twice E1 is equal to 3E2. Therefore, E1 by E2 would be equal to 3 by 2. So student, this is the answer. This is the ratio of the EMFs of the two given cells. That is, E1 by E2 is obtained to be 3:2. Correct, students? Here again, we have made use of the same principle on which the working of potentiometer is based upon. That is, the potential difference across any portion of the wire is directly proportional to the length of that portion of the wire, provided constant current is made to pass through a wire of uniform cross-sectional area. This is the principle, right? So, question number 3, we are over with this question as well. Let's concentrate on the next question now, question number 4. Okay, question number 4 is, find the value of unknown resistance X and the current drawn by the circuit from the battery if no current flows through the galvanometer. G stands for the galvanometer, right? Assume resistance per unit length of the wire AB to be 0.01 ohm per centimeter. AB is the standard resistance wire, right, of 200 centimeter. It's given 120 plus 80, that is 200 centimeter. So what to do is, Let me draw this diagram over here. A, this is B, right? Balancing point is obtained over here. This is J, and this is 120 centimeter, and this will be obviously 80 centimeter, and resistances of like this. Resistances of X and 2 ohm is connected over here, and here this is point C, and a galvanometer is connected, and at this point the connector shows zero deflection. That is, it is the case of balanced Wheatstone bridge, isn't it? So X by 2 would be equal to this resistance divided by this resistance. It can be considered to be P, and this portion may be considered to be offering resistance Q, right? And this in turn is connected to a source of EMF 4 volt. So this is the question. What we are supposed to do is, we are supposed to find out the value of this unknown resistance X and also the current drawn from the circuit, the current I. These are the two things which we are supposed to calculate, right? So, students, it's given in the question that the galvanometer shows zero deflection. Whenever the galvanometer shows zero deflection, it means that no current is flowing through this branch. So, these are the 2 points which are at same potential. In such a case, the bridge is said to be balanced. And as you are aware, slide wire bridge is based on the principle of balanced Wheatstone bridge, isn't it? So basically, X by 2 would be equal to the resistance offered by this portion divided by the resistance offered by this portion, right? Let us consider it to be, suppose M. So AM is equal to P and MB is equal to Q. So suppose this 120 centimeter length of the standard resistance wire offers resistance P, while 80 centimeter of the resistance wire offers resistance Q. Let's find its value, right? 120 centimeter. So 120 multiplied by resistance per unit length of the standard resistance wire is given to be 0.01. It is given 1 centimeter is offering resistance of 0.01 ohm. Therefore, 120 centimeter of the wire will offer resistance of 120 multiplied by 0.01. That is 1.2 ohm. Am I clear, students? Similarly, this portion, which is of length 80 centimeter, will offer resistance of 80 multiplied by resistance per unit length. That will give us 0.8 ohm. Clear, students? So, P is 1.2 ohm and Q is 0.8 ohm. Now, in the case of balanced condition, since the galvanometer shows zero deflection, therefore X divided by 2 is equal to P by Q, right? P is 1.2 divided by Q is 0.8. So let's try to solve it. It will be 1.2 multiplied by 2 divided by 0.8. Right? So 4,243. So it will be equal to 3 ohm. So the value of X is obtained to be 3 ohm. Right? So just by using the balanced condition of a Wheatstone bridge, we can easily determine the value of the unknown resistance X. Now our second objective is to determine the current drawn by the circuit. We are supposed to determine this current I. Okay, let's solve it then. We can modify the circuit, or rather we can simplify the circuit. X is obtained to be 3 ohm, right? Okay, so this circuit can be redrawn like this. This is 3 ohm, this is 2 ohm, this is 1.2 ohm, this is 0.8 ohm, and a source of 4 volt is connected like this. We are supposed to find out this current, right? This 3 and 2, they are connected in series, so it will become 5 ohm. These two are connected in series, so 1.2 plus 0.8, that will give us 2 ohm. And these two are connected in parallel across a source of 4 volt. Am I clear? So what is the effective resistance of the circuit? These two are in parallel, so it will be 5 into 2 divided by 5 plus 2. So it is 10 by 7. Am I clear, students? This is the net effective resistance of this entire circuit. Now current, it's equal to V by R, net EMF divided by net resistance offered by the circuit, net EMF, maximum potential difference, it's 4, divided by net resistance is 10 by 7. So it will be 28 by 10. So it is 2.8 ampere. So this is the net current drawn from the circuit, right? So students, we are over with this question as well, right? It was based on slide wire bridge or balanced Wheatstone bridge. Okay, now let's attempt the last question. It's again an interesting one. Concentrate on the diagram, students. Do concentrate on the diagram. Find the value of the unknown resistance X if no current flows through the section AO. Also calculate the current drawn from the battery of EMF 6 volt having 0 internal resistance. Right? So let me draw it over here. This is the diagram. This is the diagram basically. It's in the form of a triangle and it's like this. I'll redraw it again. This is where a battery is connected. Its EMF is 6 volt and here another resistor is connected. It is of 2.4 ohm, right? Here the resistance is given to be X ohm. This is to be determined, its value is to be determined. Here its value is given to be 4 ohm. This is of 10 ohm. And this is given to be of 2 ohm. And this one is given to be of 3 ohm. Okay. Now the question is, we are supposed to find out the value of this unknown resistance. And no current flows through the section AO. This is A and this is O. Through this branch, no current flows through it. That is, point A and point O must be at the same potential. Must be constant. That is, current through the branch AO must be 0. Clear, students? So, let's try to solve it. Let's break this circuit. Suppose this is point X, or rather this is point M, and let us consider this to be point N. Point M is at higher potential, point N is at lower potential. So what to do is, let's open this circuit like this. Let us stretch these 2 points like it. Let's open the circuit. So what to do is, it will be somewhat like this. Please consider on the diagram. This is point A, this is point O, it is fixed, it's given to be 10 ohm and no current flows through it. Current through this branch is given to be 0, right? You can draw this one also in the similar manner. This is 4 ohm and this one is X. This is X, right? This value is to be determined. Now what we need to do is simply open up this particular circuit, right? Point N is at lower potential, so over here it will be somewhat like this. This is point N at lower potential and this is 2.4 ohm. 2.4 ohm. Now point M, this is considered to be point M which is at higher potential. Now if you open up like this, then it will be in this particular manner. This is 2 ohm, this one is 3 ohm and it's like this. So point M will come over here which is a higher potential. And what's the potential difference between points M and N? It is 6 volt, it's given. So now student, you can relate it with balanced Wheatstone bridge, isn't it? So basically point A and O are given to be at the same potential, so no current is flowing through this branch. Therefore, it is the case of balanced bridge. That is 2 by 4 is equal to 3 by X. Am I clear, students? So since IAO is 0, therefore 2 by 4 it should be equal to 3 by X. This is the balanced condition. So what you get is X would be equal to 12 by 2, that is 6 ohm. So we obtained the value of X. It is 6 ohm. So first part is over. We are able to get the value of the unknown resistance X. Now let's try to find out the net current drawn from the battery. Right? This is where the battery is connected. This is where the battery is connected. There is a battery of negligible resistance and it's given to be 6 volt. So let's try to solve it. Now look students, no current is flowing through the branch A. Now as a result, what happens is these two are connected in series. Resultant effective resistance of 4 and 2 in series is 6. 3 and 6 is 9. So we can redraw the circuit like this. 4 plus 2, it will give us a net resistance of 6 ohm. And here 6 and 3, they are connected in series. So it will give us a net effective resistance of 9 ohm. This is 9 ohm. Clear students? Okay. Now it's pretty clear. 9 and 6, they are connected in parallel. So net effective external resistance would be given by resistance of these two, which are in parallel. It will be given by 6 into 9 divided by 6 plus 9. Isn't it? So we'll get 54 divided by 15. So what we get is 3.6 ohm. So this circuit gets changed to this one. This is 0.10. The effective resistance of 6 and 9 is 3.6 ohm, and this resistor is of resistance value 2.4 ohm. This is 0.10, and between point M and N, a potential difference of 6 volt is applied. So we need to determine the current drawn from the circuit, isn't it? So now it's become simple. So what is the effective resistance then? These two are connected in series. It will be 3.6 plus 2.4. So it will be equal to 6 ohm. Isn't it? So net effective resistance of that circuit is 6 ohm. Net potential difference applied across M and N is 6 volt. Therefore, net current drawn is V by R or E by R. It would be equal to 6 divided by 6. So it will be 1 ampere. So the net current drawn from the battery in this case is determined to be 1 ampere. Clear student? So we are done with question number 5 as well. So students, I hope you have understood the concepts involved in these questions, right? They are very simple. They are very simple. You simply need to practice more and more numericals. That's the only way you can gain in confidence. Correct students? So wish you all the best. And do study well, do study on consistent basis. Consistency is the key, right? So we'll continue in the next session. Till then, bye-bye and do take care. Thank you.